six standard integrals. In the last class we have seen first one, and first one among the six standard integral says that integration dx divided by x square plus a square equals to 1 by a into tan inverse of x by a plus c. Still we have 5 more standard integrations, and all these are very important for 5 marks as far as the theory examination is concerned. So write second one out of 6. This will be class number 12 in our very big topic integration. So second theorem or second standard integral show that, or it may be given as prove that. Show that integration dx divided by square root of a square minus x square equals to sine inverse of x divided by a plus c is understood. So let's have this theorem proved. Write proof or solution. So we start from integration I. Let I equal to integration of dx divided by square root of a square minus x square. Call 1. Because of we have square root of a square minus x square, from our past knowledge already given as a form of table, whenever there is root of a square minus x square, the ideal substitution is x equal to a sin theta or a sin t. Put x equal to a sin theta. Call 2. Differentiating with respect to theta, or differentiating with respect to theta dx by d theta. Right hand side, a into differentiation of sin theta is cos theta, or only dx equal to a cos theta d theta. Now we write that from 2 and 3 using in 1. Right, next step, from 2 and 3 using in 1, I becomes as integration. dx is a cos theta d theta. Divided by square root of a square minus x. X is a sin theta. A sin theta whole square become a square sin square theta. Now in the denominator, a square common, outside root it becomes a. That is integration a cos theta d theta divided by, here a square is common. At the same time, outside the root a square become a into root of 1 minus sin square theta. A will cancel out. That is equal to integration cos theta divided by. Again from trigonometry, how much 1 minus sin square theta, that is cos square theta, it become root of cos square theta. That is equal to next step, integration cos theta divided by cos theta. So consequently cos theta will cancel out. The left is only integration of 1 d theta. Like how know integration of 1 dx is x, integration of 1 dt is t, here integration of 1 d theta will be theta plus constant c. But now replace back value of theta without failure. Replace value of theta or substitute back value of theta. From 1, what we can have is that sin theta equal to x by a, theta becomes sin inverse of x by a. From 1, what we get is that sin theta equal to x by a implies theta equal to sin inverse of x by a. And let's replace value of theta. What it becomes is that sin inverse of x by a plus c. So we got the desired answer. Write it again freshly, in detailed form. So integration dx divided by square root of a square minus x square equals to sin inverse of x by a plus c. Highlight it. Underline it. So this standard integration result can be extended. Extended form of this integration formula. You can write as an extended form. The extended form is integration dx by square root of a square minus of bracket x plus or minus alpha whole square. You must see the format, that's all. Instead of x we have x plus or minus alpha. So the result is sin inverse of x plus or minus alpha whole divided by a plus c. See, like for example, how this formula will be used in the coming hours. For example, integration dx divided by square root of 144 minus x square equals to. Very first we shall write 144 as a square of a suitable number, and 144 is suitable for 12 square. 12 square minus x square. Now it is in the form integration dx by root of a square minus x square. So this formula is suitable. Now a means 12. Answer is sin inverse of x divided by 12 plus c. As another example, suppose if you have integration dx divided by square root of dx by square root of 14 minus x square. 14 minus x plus 2 whole square. That is equals to, one step we have to take, dx divided by square root of 14 cannot become 14 square. 196 can become 14 square. 14 remains as root 14 square. minus x plus 2 whole square. So it is in the form of integration dx by root a square minus x square. Instead of x we have x plus 2. Answer sine inverse of x plus 2 divided by root 14 plus c. Your next third one. Third standard out of 6. And all these 6, one of these you will get, not all 6. Important for 5 marks. Like third one. Show that, or it may be prove that. Show that integration dx divided by square root of x square plus a square. Dx by square root of x square plus a square equals to log. With modulus understood. Log of x plus square root of x square plus a square plus c. First step, take a solution or proof. Let I equal to integration dx divided by square root of x square plus a square. Refer the previous classes. Since root of x square plus a square is present, we need to put x equal to a tan theta. Because of square root of x square plus a square is present, put x equal to a tan theta. If x is a tan theta means what is tan theta? X by a. What is theta? Tan inverse of x by a. Keeping that in mind, call 2. Differentiating 2 with respect to x or with respect to theta. Better in this case with respect to theta. Dx by d theta is equal to a secant square theta. Or only dx equal to a secant square theta d theta. Now say from 2 and 3 using in 1. That word you write yourself. From 2 and 3 using in 1. Or from 2 and 3 1 changed. Anything can be written. I equals to integration. Dx means now it becomes a secant square theta d theta. Whole divided by square root of. What is x? A tan theta. X square become a square into tan square theta. Plus a square remains same. Next step, integration a secant square theta divided by square root. Inside square root, a square common. After a square being common, left is tan square theta plus 1. Further, integration 8 secant square theta divided by square root of a square is a into square root of how much 1 plus tan square theta, that is equal to secant square theta. A cancels. And also root of secant square theta is only secant theta. That is equal to integration of secant square theta by secant theta. Secant theta will cancel. Left is only integration of secant theta. Now you observe list of formulas. In the past classes we have seen by standard formula list, integration of sec x is log of sec x plus tan x. Here integration of sec theta is log of sec theta plus tan theta. So now I equals to log sec theta plus tan theta plus constant C and C. But we want our answer only in the format of x. So we shall write back value of tan theta. What is tan theta? X by a. And also sec theta we shall convert in the form of tan theta. That is equal to logarithm of 1 plus tan square theta is secant square theta. So secant square theta become root of 1 plus tan square theta. Plus tan theta remains same. So that from 1 we can write tan theta as x by a. Since tan theta equal to x by a from 1, we use here. So this value of tan theta we shall replace the result of integration. It is equal to now logarithm of bracket square root of 1 plus, what is tan theta? X by a, tan square theta become x square divided by a square plus tan theta means x by a plus c. That is equals to logarithm of bracket root of inside root, what is common? A square into 1 a square. What it become? A square plus x square divided by a square plus x by a. Further, equals to logarithm of bracket root a square plus x square. This is square root of a square. Square root of a square is a plus x by a plus c. That is equals to log bracket. Within bracket LCM is a. After LCM we get root a square plus x square plus x plus c. This is in the format of log of m by n. Log of m by n is log m minus log n, means it will be log of x plus root x square plus a square or x square plus a square or a square plus x square minus log m means log a plus c. Finally, log x plus root x square plus a square c is constant, log a is constant, sum of two constants is again a constant, so we shall write c minus log a as another constant, somewhat big C. Or you can write a also. Constant does not matter. It because it is arbitrary. That's the required answer. You can write here where capital C equal to small c minus log a. This is third and important result. Right, lastly, yet again in a standard formula manner. 1 second, actually. What we are writing is that integration dx divided by square root of x square plus a square equals to log. Modulus you have to maintain because logarithm of negative numbers are never defined. That's why even though mod is not there, it is understood. Log of modulus of x plus root x square plus a square plus c. Better highlight it. I mean underline it. You also write its extended form. So we write extended form. Extended form. The extended form is integration dx by square root of x plus or minus alpha whole square plus a square. No change in format. Only thing in place of x we have x plus alpha or x minus alpha. So answer format do not changes. Only x to be written by x plus or minus alpha. That is log of modulus of x plus or minus alpha plus square root of x plus or minus alpha whole square plus a square. This is an extended form of last theorem. That is theorem number 3. This also better highlight. So you write, for example, means how this formula we are going to use in the coming problems. For example, integration dx divided by square root of x square plus 49. That is equal to integration dx divided by square root of x square plus 49 means how much? 7 square. Here there will be some confusion to the student's mind. It happens only with initial days. But when you have a lot of practice, there will not be any kind of confusion at all. Because you will not give importance to square root, presence, are not present. If there were no square root, it will be in the form of dx by x square plus a square. Then answer is 1 by a tan inverse of x by a. Looks like same, but you try to have the presence of square root in mind. It is square root, so this formula is only suitable. Answer. What is the answer? Log, modulus, x plus root x square plus a square. What is a square? 49 plus c. Another example, integration dt divided by, instead of x we increase t, does not matter, square root of t minus 3 whole square plus 5 square. Here what is important is that out of 6, which format is actually, it is matching format. It is matching format, integration dx by root x square plus a square. So only that answer to be written. But instead of x we have t minus 3. And for a we have number 5. But no change in answer format. That means what is the result? Log modulus of t minus 3 plus square root of t minus 3 whole square plus a square. What is a square? 5 square. Nothing but can be written as 25 plus c. Okay. I hope you are getting the concept correctly in your mind. And more importantly, in addition to earlier some basic formulas, memorize these 6 formulas also in mind without fail. Next question. Next standard 1 out of 4. Next. Fourth, out of 6, show that. Actually, fourth and the third very much resembling one another. Means they are same in their proof and in their appearance also after getting the last result. Show that. Integration dx divided by square root of x square minus a square equals log of x plus root of x square minus a square. Plus constant c and c. We start this theorem proof, right? Proof or solution. First step, begin from I. Let I equal to integration dx divided by square root of x square minus a square. Call 1. Put x equal to a secant theta, because of root of x square minus a square is present. Put x equal to a secant theta or a sec theta. After this, differentiate dx by d theta equal to a into differentiation of secant theta is secant theta into tan theta. From this, only dx equal to a secant theta into tan theta d theta. Say this is 2, this is 3. Now write that from 2 and 3 using in 1. So from 2 and 3 now, 1 changes as I equal to integration dx means a secant theta into tan theta d theta. Divided by square root of x square. What is x? A sec theta. Whole square become a secant square theta. Minus a square remains same. Now inside square root, a square is common. That is equal to integration a secant theta into tan theta d theta divided by square root of. Within root means inside root we have a common is a square, in the bracket left is secant square theta minus 1. That is equal to integration a secant theta tan theta d theta divided by square root of a square in secant square theta minus 1 formula is how much? Tan square theta, because 1 plus tan square theta is secant square theta. That's why secant square theta minus 1 is tan square theta. That is equal to integration a sec theta tan theta divided by here square root will cancel out leaving at how much? A tan theta. A will cancel out. At the same time, tan theta also cancel out. Hence, I equal to only integration of secant theta. Further, integration of secant theta is log of sec theta plus tan theta. Plus C. But we should get our answer back in terms of x. What is sec theta? X by 8. And to have that stage of writing value of sec theta, we shall write better tan theta also in terms of sec theta. Tan theta formula is secant square theta minus 1. Plus constant. So that now we can write value of sec theta. Replace sec theta as x by 8. I mean replace sec theta is equal to x by 8. So now I becomes as I equals to log bracket how much x, how much sec theta, x by square root. Sec square theta becomes x square by a square minus 1. That is equals to log x by a plus square root of inside root LCM a square. What it become? X square minus a square divided by a square plus c. Further, log bracket x by a plus square root of x square minus a square and also square root of a square become how much? A plus c. Further steps, I equals to log bracket inside bracket LCM A. After LCM A, in the numerator we get x plus root x square minus a square plus constant c. Now it is just like log of m by n. Log m minus log n means log of x plus root x square minus a square minus log a plus c. But what is c? Constant. Log a also constant. Sum of two constants is again a constant. We shall write all this is equal to some other constant. So finally, what we get is that integration dx by root of x square minus a square equals to log modulus understood. Log of modulus of x plus root x square minus a square. And c minus log a written as some other constant, say somewhat big C, that is capital C. This is for standard integration and most useful in the coming types of problems. I hope that yourself you can manage its extension. What is extension? Dx by root of x plus or minus alpha whole square minus a square equal to log. Instead of x, you must write x plus or minus alpha. Here also x plus or minus alpha. Hope you can manage, you can understand yourself its extended form. Let, for example, how this formula we are going to use in the coming problems, coming hours problems. We write for example, integration dx by square root of x square minus 9. It is equal to integration dx by square root of x square minus 9. What is 9? 3 square. But you have to take in mind correctly which formula it will matches. So don't take the formula a square minus x square, because a square minus x square completely away from x square minus a square. Both of them never coincide each other. So it is in the formula dx by root x square minus a square using that formula. Answer log x plus root x square minus a square. What is a square? 3 square. Nothing but 9 plus c. Still we have two more standard theorems, and after that type 4, type 5, type 6, type 7, type 8 problems based on using all these 6 formulas plus earlier formulas also. I hope you are understanding well all these standard results quite clearly. I hope that. Thank you. We shall continue the next class. Two more standard results plus upcoming types of